Well, again, good morning, good afternoon, good evening, wherever you are, different parts of the world. I hope you're keeping cooler than I am. I'm just in India. It's been extremely hot, so around the world, there's a heat wave, and a lot of people think it's because of the climate change. And so we have a perfect talk for you, which has to do with sustainable solutions with communities, humanitarian engineering. Dr. Kevin Moore is a professor at the Colorado School of Mines in the Department of Engineering, Design, and Society and the Department of Electrical Engineering. He received his BS and MS degrees in electrical engineering from Louisiana State University and from the University of Southern California, respectively. He received his PhD degree in electrical engineering with an emphasis in control theory from Texas A&M University in 1989. At Mines, he was previously the Vice Provost for Strategic Initiatives and the Dean of Integrated Programs and the Interim Director of Mines Division of Economics and Business. More details available at the link that was sent to you in the email. So thank you so much, Dr. Kevin Moore, for joining us. And without taking any more time, I'm going to hand this over to you and turn off my screen, okay?
All right, thank you very much, Krishna. And thank you to the organizers for inviting me to give this talk. Krishna gave my greeting, which was good morning, afternoon, and evening, because I know the attendees are from all over. But whether you're viewing this later or today, thank you very much for coming. I'm the executive director of our humanitarian engineering program at my institution, and this talk is in with collaboration with some of the other leaders in our program. So I hear some noise in the background. I hope that's not going to last. It's on my side, I'm afraid. But let me just briefly say, I'm from the state of Colorado in the USA. We are at the foothills of the Rocky Mountains, as you see here. We are about 300 faculty, about 6,000 students. We've been around almost 150 years. We're considered an R1 research institution, and we have this moniker, Earth, Energy, Environment. But we have a more compelling story, which is discovery and recovery of the Earth's resources, conversion of those resources to material and energy, and developing advanced processes and products with that material and energy, as well as fundamental research. Since 2004, we had another set of words: economic, social, and environmental systems necessary for a sustainable global society. So we have been saying these words nearly 20 years. And I like to believe that here at the Colorado School of Mines, we really believe in this. But when we look at the world around us, we have to ask, what do we mean a global sustainable society? What do you see in this image? So I myself see a line, and I see a world divided. Above the line, we see wealth and affluence. Below the line, we see poverty. Above the line, we see functional infrastructure to meet all of the Maslow's needs in the hierarchy of people's quality of life, from housing and transportation, energy, water, sanitation. Below the line, often the infrastructure is not effective. Access to education is different across the lines. Access to healthcare, political empowerment versus disenfranchisement. It's a world divided that we live in. I think all of you as engineering educators know this. And despite our technical prowess, the CDC in the US reports 2 out of 7 people on the planet are not able to have a safe and comfortable sanitary daily toileting experience. I think we as a society need to do better than this, and engineers should be part of helping us do better. So humanitarian engineering is a response to the need to do better. I think largely our program was generated and motivated by concerns over social justice, whatever that might mean to you. But we have taken an approach to center our program on community with the hopes of leading to that sustainable global society. So what do I mean by humanitarian engineering? Well, first of all, it is a signature student experience, a signature educational program at my institution. We started this program in 2003, actually. We were coming up on 20 years. We are possibly the first curricular program in the US with this name. It was started with a grant from the Hewlett Foundation here in the US. Our mission is to educate engineers and scientists to work as partners with communities that are seeking to enhance their social, environmental, and economic sustainability. And there are a number of words in this mission statement that we'll be working our way through. I hang around more lately with social scientists, so I say there are a lot of things to unpack in this statement. And so that's what we'll do in much of the presentation today. But more than a program at our institution, it's also a different way of thinking about and doing engineering. And it's not just about the social aspects, but it's truly about social technical integration. And perhaps eventually a new discipline with its own canon of fundamental knowledge. But I want to emphasize in these words on the screen that it's very much about social scientists and engineering faculty members who take each other seriously. Those of you that have been around with as much gray hair as I know that this is not always the case. In the coffee rooms, around the water cooler, as it were, in the hallway, social scientists and engineering faculty have not always taken each other seriously. But as we think about engineering, I would say that we must take each other seriously to solve this problem of a divided world. So let's think about engineering a little bit. Brad Allenby had a book called The Theory and Practice of Sustainable Engineering, and this was summarized by another professor from Michigan State, 3 levels of technology. At the one level, and frankly, the level I was trained at as an engineer 40 more years ago, is technology as an artifact. What is it? What does it do? What is it made of? And this is very much about solutions by engineers, designers, and scientists who are really solving for design parameters. And I would say engineering education does well here. The next level is technology infrastructure. What other technologies does it rely on? What are the supply chains? At this point, the trade-offs and the need for interdisciplinary collaborations rise, but it's still mostly engineers and business people talking with each other. And I would say engineering education does okay here too. However, as you move up in complexity, you have the regulatory, social, economic, political considerations. You have to consider user and non-user impacts of what you do. You need to consider equity and inclusion. So there are trade-offs, negotiations between many different stakeholders, and the power dynamics between them. And I would argue, and I think it's not hard to argue, that engineering education doesn't do well here. Our students don't get a training at where this overlaps with their technical education. But this is the level, the system complexity levels, where the wicked problems that we encounter in the Sustainable Development Goals or the NAE Grand Challenges, this is where they live. We have to do better in our engineering education at this level. I'll just give one small bit more discussion kind of at the conceptual level, and I would posit that if we don't have a complex and nuanced response to engineering education towards these complexities, we won't really be able to prepare our students to be the ones who are making the difference. And you could say that a root cause of the problem is that historically, we as engineering educators have taken a very reductionist approach to education. We separate social from technical. We separate context from the analytical content of what we do. We also even separate values from practice. We try to promulgate, or historically, we've promulgated the idea that technology is neutral. It's a sequence of discrete analytical skills. And this often leads us to think that, well, if we simply add some more criteria in the engineering design process, we'll be able to contribute and solve any social outcome and social problem. But this is a fallacy, I believe. I believe that we need to, in fact, have a deliberative integrative education that connects the engineering and social. And that's what we're doing in our program in humanitarian engineering. And I thank my department head for these ideas, Dean Nusma. So I'm going to mention 7 aspects, maybe briefly, maybe not so briefly. I'll probably spend more time on others. 7 facets or aspects of humanitarian engineering. And these first bits, really up through number 5, I would argue are not about us at the Colorado School of Mines. These are ideas we've developed here, but I would argue these are ideas that expand more broadly and could be incorporated in engineering education writ large. And then I'll describe some of the things we have done here. So one of the key things that we put forward is that meaningful engineering requires new ways of engaging communities, of evaluating projects, and most importantly, critically examining engineering practice. This is not common for engineers. We think about maybe our designs, but we don't think about the larger critical questions which focus on the politics of problem definition and solution. We teach our students, and I believe our students should be taught across all engineering to ask the questions, what is engineering for? What is engineering? Who gets to do it? Who gets its benefits? How do those answers to questions determine who gets into engineering and who gets out? Who gets to define what is development and progress? What are the assumptions and practices that underlie global development? Who gets to do that? So there are 2 key concepts that have become pillars of the conceptual ideas we've been promoting and others. One is we should not go around saying that engineers are problem solvers. We should say that first they are problem definers and then they are problem solvers. Many of you who have had experiences in development and in engineering for good know that there are lots of problems solved that weren't really the problem. And that's because we often come in as engineers thinking a lot of what we bring to the table, and we don't ask questions and understand the needs of the communities involved. So that's the second piece. We believe that we should jointly define problems and co-create just and sustainable solutions with the stakeholders, with the communities. So through this type of critical reflection, our humanitarian engineering students learn to understand problems in their context, to ask the right questions and to listen contextually, to co-design as partners with the people they're trying to serve. And they learn that real-world problems involves working with other professionals as a team, policymakers, lawyers, business people, social scientists, anthropologists, and that technology alone is never the answer. So we consider this intersection of engineering with society. And I also point out that we're often focusing on the vulnerable communities. I don't claim that we're the only people doing this. We're part of a big movement. Some of you may know the organization Engineering for Change. So you might collectively call a number of programs Engineering for Good. They've recently produced a number of very nice reports that look at North America, Latin America, Asia, Australia, and New Zealand. And they identify degrees, research centers, experiential opportunities, and conferences. On the right, you see a snippet from one of the reports. You can find these online quickly just by searching here, bachelor's degrees, master's, and PhDs in the US. And they have lots of different names: international development, sustainable systems, global development, humanitarian engineering, peace engineering. We've heard in this seminar series about that before, and many different minors and certificates. But no matter the name, the important role engineering can play in improving lives is increasingly being recognized. And I would say for us in our humanitarian engineering program, engineering for community development, both domestic and global, is an important aspect. So let's talk about that. Our faculty have been developing various criteria for engineering for community development. And this is informed by scholarship and critical analysis. We believe that engineering, and by then connection engineering for community development, these projects should consider and honor criteria that puts people first. We should champion local economic diversity, political self-reliance, reduction and reuse of energy locally, enhance biodiversity, and social justice. Another aspect, though, is that you often think about this engineering for good as being associated with NGOs, non-governmental organizations, nonprofits, Peace Corps, USAID, etc. But the majority of our students go to work in companies. And I would argue that humanitarian engineering concepts apply to corporate careers as well. And this introduces this concept of corporate social responsibility. So I'm going to tell you a story of a tale of three costs. And this was told to us by a former vice president of a large mining company. If you, and some of you that have been in this engineering and have observed engineering industry for years may recognize this story. If you were to go back to the pre-60s, it could be argued that the mission of corporations was profits. And really, you see outside the circle, safety, environment, communities. Those were the costs of doing business to companies, not integral to their culture. But what happened in the 60s and 70s, and I'm old enough to have seen this a little from some early jobs of my own. Safety gradually moved away from a cost to a core value. It became part and parcel. It is just what you do in a corporation. It's inside the culture. The 70s and 80s saw the same thing happening with environment, that what's good for the planet is good for the company. And finally, what we see today in many industrial sectors is the notion that community is important for garnering a corporation's social license to operate. You can't just move into some rural jungle valley and just start digging stuff out of the ground because you need electric batteries for your electric cars. You've got to get the permission, as it were, of the communities that live in these locations. You have to have a social license to operate. This really came out of mining, where the cost of conflict in the extractive sector, if you have conflict, something like the Dakota Access Pipeline, a recent one in the US, if you have that during the initial exploration, the costs are much less than if you have it during operations, where it can cost you millions per week if you're shut down by local community unhappiness with what you're doing. So this has really led to the idea that corporate social responsibility will become, and really is, an internalized core value in business. It's true already in mining. It's true in oil and gas to a lesser extent. It's quite pervasive these days in construction, aerospace and defense more recently. And you may, some of you know that the Business Roundtable, which is a collection of a number of Fortune 500 companies, 100 of them signed a letter saying that they believe that the responsibility of business is to its stakeholders, not just its shareholders. Now, this was roundly criticized by people like The Economist and others, but nevertheless, it's an indicator of how industry is starting to see this notion of people, planet, and profits. So much so that people like the Blackstone Group are no longer giving out money to invest in extractive enterprises and resource activities unless the environmental, social, and governance considerations, a kind of a CSR focus to finance. Unless those are considered, you're not getting money from that large investment world. And so this triple bottom line, what's good for society is good for the planet and good for the shareholders, is something that, you know, people could say this is simply the domain of social scientists, but I think true CSR can be achieved when engineers design, build, and operate with the goal of community acceptance. So we've put a CSR track in our program, and I would submit that engineers and companies should embrace CSR as a way to manifest socially responsible engineering. So I've just introduced one more word. So I've used the word humanitarian engineering, and I've said as a part of that, you have engineering for community development, you have this corporate social responsibility. Socially responsible engineering is another phrase that you will hear along with engineering for good in this arena. And I would say that students are encountering this in a number of multiple and possibly even competing notions. Global performance standards coming out of the finance world, societal aspirations like the Sustainable Development Goals or the NAE Grand Challenges, our professional codes, the engineering ethics class that they normally take. When they get to work, they will encounter socially responsible policies and programs at their employer and in corporate settings. And today, expectations from communities and even students' own sense of self ethics, identity, professionalism. So I think all of these things are rolled up into this concept of humanitarian engineering. Through our ECD and CSR components, we're offering a framework from which students can make sense of this landscape. And this framework we have been developing, we specifically, Smith and Lucina, Juan and Jessica, have been developing this in the archival literature. The idea that engineers, in working with communities and in trying to be socially responsible through their practice, should have some very specific approaches. One is to understand the structural conditions and power differentials among the stakeholders of your project. You should then listen and in context all those stakeholders, especially those that are marginalized, so that you understand what it is that they need. And then you should work with those same people to identify possible solutions and how, you know, shared social, environmental, economic value can be brought to bear on defining the problem. And then once you have that problem defined in that collaborative way, you adapt your decision making to promote those shared values. And this is very important. I probably should have put this part in bold, but you can't put everything in bold. It's very often the case, and we see this in some of our student activities, where you make the decision that it's not possible to move an engineering project forward because it's actually not aligned with those shared values of the community. And that's where that critical thinking comes in, to not just barge ahead and design something because you can, but to actually design when it makes sense. And finally, something we don't do as much of in engineering, right? We typically spend less time assessing what we've done. Certainly in our engineering education, it's become more of an understanding that we need to have evidence-based pedagogy. But typically with our senior design projects, they get out the door and they're gone. And typically the students say, oh, if I could do that senior design project again, it would look so different. But that collaborative assessment of outcomes with stakeholders is an important part of being a socially responsible engineer. I'll say just a few more things in terms of the mindsets that you need to transcend the technical. And this is so hard for us as engineering educators because we're trying to teach them thermo and heat transfer and circuits at the same time that it's becoming clear they need to be socio-technically adept. I think our students, the socially responsible engineer, needs to have a multi-dimensional mindset that honors people outside their discipline. You know, back in the day, if we said we were doing a multidisciplinary project, we meant that electrical engineers and mechanical engineers are working together. That's old school. That's not multidisciplinary. Okay, it is, but the larger view is that we have to honor and understand the contributions of sociologists and historians and political scientists, as well as engineers. Our students need to become system thinkers in a stronger way than today. They need to have a global perspective, and they need to honor diverse contributors. A socially responsible engineer, a humanitarian engineer, is a design thinker who's a problem solver first, a second rather, a problem definer first, and who asks the question, why are we engineering in the first place? We should be human-centered and entrepreneurially minded, like the Keen Network's 3 C's, curious, connected, and creating value. These should be inherent in the mindset of our engineers that we produce. And ultimately, they should be mindful of the right motivation with an intent and desire to be socially just and focusing on making society better, especially for the marginalized populations in the world. So those are some concepts around humanitarian engineering. I've alluded to the fact that we're working in a variety of ways to try to build foundational underpinnings, archival research, evidence-based inquiry. These are important to make humanitarian engineering kind of a credible academic activity. So I would say it is a credible and exciting academic area of inquiry because of the high interdisciplinary intersection between social scientists and engineers. This is a space where you can really ask deep and serious, constructive, critical reflection. What is engineering for, and who is it for? And I would also say it's a fertile ground for funding. We've had a large amount of funding in federal grants in the US since inception. We've also had significant philanthropic funding in addition to this. You can publish this, and there are now many conferences and networks. You can refer back to the Engineering for Change reports to see those. These are just books from our own team, books on engineering and justice, engineering sustainable development, books on social responsibility, engineering and war, etc. So I'll just give you some sample in the research arena. You know, we have students working with homeless populations in Denver conducting research. We have master's students doing thesis on e-waste recycling in Argentina, construction waste recycling in Colombia. We have projects on community empowerment with a global NGO called PACT, or PACT World. And I'll mention one on artisanal gold mining briefly as an example of what humanitarian engineering brings to the table. I don't know how many of you are aware of artisanal mining. There are two big hotspots right now. Gold has been a well-known one for years. There's a new one primarily in the Congo around cobalt. As we have such an increase in the desires for electric vehicles, etc., the need for some of the critical minerals and metals that go into these renewable technologies is quite large, and much of these resources are extracted in the ways you see here on the screen, through artisanal miners, not necessarily connected directly to companies. So we have a project from the National Science Foundation called Responsible Mining and Resilient Communities. Juan Lucena is our PI on this, and there are multiple others. You see a large number of sponsors and partners actually across the top, all of the various symbols. what people may not know is about 20% of the world's gold supply comes from artisanal gold miners who are putting in probably 80% of the effort in mining that goes on untold. And it's a major source of pollution for of human-generated mercury pollution. And you know, this gold is in everything, and it's actually important for much of our electronics, but it's financing lots of violent conflict and money laundering. And so we've had this project that's tried to look at how to overcome some of these problems related to mercury and heavy metal pollution, the deforestation that's associated, and really the social pieces, because in many parts of the world, artisanal mining is considered illegal mining, and the people that do it are disenfranchised and typically live in often severe poverty, just making a living, and they're subjected to just horrible health situations. So in our project, we've tried to ask, how do the social, environmental, and technical dynamics in artisanal small-scale gold mining systems intersect and influence each other? And what are the risks that are known about and perceived, and what are people already doing in these communities, and how can we try to find better ways to mitigate those risks? So I'm not going to read all of these, but I'll just say that our approach has been to try to apply these concepts of socially responsible engineering and bring people together to have this interchange to understand what is the context in which they are living in a community that deals with the artisanal small-scale gold mining. So we convened several workshops, one in 2017, and then a large one with 70 attendees in 2018. This was one of the important ones. We brought our students, our faculty, we brought miners, lawyers, nonprofits, government entities, mining companies, mining engineers from mining companies, and spent several days understanding that context, listening to the communities, and then co-designing and establishing a path forward for co-designing solutions. So an outcome from this, we have a thesis project which has been developing a framework for co-designed gold processing plants in Colombia, where artisanal miners can come to kind of a common location in the community to have their gold processed in a way that allows better containment of the mercury and less contamination. And what's interesting is one of the main and largest gold commercialization companies in Colombia is now looking at discussing how to finance and build a pilot of this this co-designed gold processing plant, because the large corporations understand that if they can mitigate environmental impacts and community impacts around gold mining, it's good for their bottom line as well. So this was one example. Now I'm going to switch gears and start wrapping this up within another 5 minutes or so. Sorry, that's moving. At our institution, when we have this HE curriculum plus at Mines, we have 2 undergraduate minors, we have focus areas that are part of a degree, we have the master's degree, and we have a design studio for our senior designs. We currently have graduated about 120 students, but more of those were since 2012, and we're graduating about 10 a year now. We also put about 300 students a year who aren't in the minor into about 20 HE related classes. And we have some student clubs. We also have an alumni interest group. So many of the alumni of our institution have worked in the extractive industries, and they've experienced social responsibility firsthand in their career. We've had significant funding of undergraduate scholars, graduate scholars, postdocs, and Peace Corps prep. And as I mentioned, we've had a fair amount of funding. And we have about 10 core faculty and 20 allied. So nearly 20% of the the mine's faculty are in some way connected. That should say 10%. That was a mistake. I did want to put this up. This is a bunch of words. Maybe it's too small to read depending on the screen you're on. But these are a list of the courses that we offer. And I want to call out one. A very important course for people that want to get into this arena, whatever you call your program, peace engineering, humanitarian engineering, engineering for global development, engineers have to be taught mixed methods of inquiry that are used in the social sciences. It's not a good idea for engineers to go out and do a survey in the community without getting advice and guidance from social scientists who know how to do that statistically accurately, and so much of the research and community-based activities is qualitative, not quantitative. You need to learn to do interviews, etc. So that's kind of a comment I wanted to make in terms of courses that we think are important. In our graduate level, we have that same course as a requirement. Our graduate program gives 15 credits of core humanitarian engineering and we say and science. Our graduate program is humanitarian engineering and science. And then they also pick up 15 credits from a disciplinary track. And right now we're collaborating with a number of different academic departments. We even have two new tracks, one on data science and one on humanitarian robotics. It is truly an interdisciplinary program. It's the print may be small at the bottom, but we have collaborators from all the departments you see there. And across these departments, in our program, we have kind of these shared areas of practice. And we've been talking about corporate social responsibility, community development. Social innovation is a new area we're developing into. And the engineering for social justice is pervasive. But the other thing is risk perception and mitigation. This is something that's growing in our program because of our intersection, if I go back here, with our geophysics and geological engineers. You know, geophysicists, geological engineers, mining engineers, petroleum engineers, they are often out in the communities so much more than say our electricals and mechanicals, who tend to maybe see communities through corporate practice. But many of the earth science related engineers are actually out where they're dealing with natural and man-made systems that cause risk to communities. So risk perception and mitigation is a very important emerging area of shared practice in humanitarian engineering. If you look at the Engineering for Change report, you will see that a lot of the programs that are out there at other schools are very much aimed at actually going out into communities and doing projects. And we do some of that. It's not been our biggest focus. Our biggest focus has been more in the curricular piece. But as part of the curricular piece, we do try to go from some theory to practice in our humanitarian engineering projects. And you just see some pictures here, and whether it's mountain bikes for quadriplegics, which as a group you may consider, you know, the group of people with mobility disorders as a community. It may not be a community in place, but it's a community nonetheless. Or so mountain bikes for quadriplegics, or solar powered pumps and post-harvest storage solutions in Africa. A Native American reservation where we're looking at water or energy efficient housing. And our students get these through their undergraduate courses, these projects, or also through two clubs. We have a club called the Socially Responsible Engineers and Scientists that our students run. We have Minds Without Borders is the Engineers Without Borders program at our school. We also have a student club called Geophysicists Without Borders, and that's actually a national club. Our thesis-based graduate students do independent research, or they do practicums. So to the deans here, I want to say that humanitarian engineering does attract different people and viewpoints to engineers. Social scientists, as I've mentioned, about 75% of our HE students are women. It brings new approaches to problem solving that can amplify the impact of our students. It brings new sources of funding and new dimensions to university, industry, societal collaborations. So I would really challenge the engineering deans who are listening to think ways to include the precepts of humanitarian engineering in your own program. And I think with that, I'm at the end. This has been an exciting transformational program at our institution. We're able to help students understand how to critically reflect. We've got these focus areas on doing community development and corporate social responsibility, and where these intersect with communities and this broader notion of socially responsible engineering. And it's an arena ripe for scholarship and curriculum and for making a difference through action. So that's it. I'll leave it open for questions now.
Thanks a lot, Kevin. What a fascinating presentation indeed. And I'm sure many people have questions about it. I myself have quite a few, but let's start with the audience. Almost 200 people in the audience here from around the world.
Krishna, you want me to remove the screen sharing now?
Yeah, you could. That might not be a bad idea. That's pretty good. Yeah, you can. Yeah, there you go. Okay. So unless somebody wants you to put back a slide or something.
Okay, we can go back.
Okay, we always do that. Okay, let's start the dialogue, folks. I guess the first obvious question from Rajesh is those who go through your minor in humanitarian engineering, what kind of job opportunities do they have? Where do they go after they have this really nice education?
So I wish I had compiled a nice statistical slide, but I have some 30 additional slides that detail individual students and where they went. And I will tell some things that is not just complete glad. For the undergraduates with the minor, to be completely honest, they get their jobs because of their disciplinary degree. So all of the students are doing a minor. And so they've got a degree in geophysics or environmental engineering or electrical engineering. Their minor is a benefit. I came from South Louisiana, so we call it a lagniappe, something special that's added, a French word. So they end up in either consulting companies that are, they tend to self-select and look for people that are doing things like community solar. They look for geophysics consulting firms where they know they're spending a lot of time in the communities. Some of them go to big petroleum engineering majors, but because of their minor, they find themselves connecting with the sustainability or environmental health and safety teams. I would say of the people getting the minor, maybe close to 10% are going to Peace Corps for a first job, and another 10% are finding a way to the NGOs of some form or another. But
okay.
The master's students, it's much more complicated, and the program's only 2 years. But it is true that at this moment, humanitarian as a concept is an add-on to the existing degree.
Okay, it's really fascinating. Let's have some conversations. Anybody from the audience, from the panel, might want to unmute yourself and jump in. Ramiro, Natarajan, would you like, Hans, would you like to ask some questions at this point? Come in. Anybody from the other audience, I can unmute you if you want to just send me a text message saying I want to speak. I've got a few more comments coming in, so let me.
Krishna, this is Hans. I'm going to not just wait until the end of this particular. Kevin, this is one of the most creative, important presentations that we've had in our series. I just want to say that. And as you know, I'm a cultural anthropologist, scientist, and joined the engineering community about 13 years ago. particularly because some leaders wanted very much to build connections, with the other disciplines, as you said. But I think there's a very thoughtful comment you make. By the way, also I was a Peace Corps volunteer, just to share that here with you. But one comment you made at the beginning is that we don't take each other seriously, the engineers and the social scientists, as they work together. Can you, I'm quoting you, I wrote it down. I'd love to hear your comment on that.
Well, yeah, I don't want to get people mad at me by saying something like that. I think it was certainly true. But, well, let me tell you the basis for that. In my own education, any colleague student said, oh, I have to take my humanities, arts, and social science credit this semester. I hate it. Most of my faculty said, no, don't take extra classes in the humanities. You don't need that. Take extra thermo. I think the traditional engineering education that came out of the 50s up until maybe ABET 2000 was very techno-focused. And even today, my students here will often say, not my students perhaps, but the students at our school will say, why do we have to take these social science classes? Now, I think it's gradually changing, and I think there are a couple of reasons. One of those reasons is because in the engineering education community, we began publishing true scholarship on pedagogy as a result of activities of ASCE and GEDC. It's understood that the way you go about studying what ways to do engineering education, to do that properly, you need to bring social science skills in. So once people figured that out, then they started to say, oh, this might also have some impact in my work as an engineer because I have to deal with people. So I think as the NAE Grand Challenges came up, as we start to think more about sustainable development goals, people are just gradually understanding this intersection. But I think part and parcel of our education, especially if I can say old school with all the white hair and white beard I have, I think the old school was that, well, engineers are stuck in a cubicle calculating and they don't know anything more than that. And engineers think, oh, those social scientists they don't have any rigor. I hesitated to say the rigor word because the rigor word just creates lots of arguments here because there's this sense among the social scientists that the technical engineers don't think they are rigorous, but in fact, what they do is so hard.
So yeah, can we move on to maybe other questions? A few more people are waiting.
Sure.
Oh, yeah, Natarajan, would you like to jump in? You had your mic open.
Thank you. I would like to make 3 or 4 points. First of all, I think this lecture has really given us, it's opened our minds to what engineering is for and who is it for. I think that these 2 questions are so important for students to understand why we are teaching and learning engineering. Secondly, I would like to point out in recent times, some aspects of humanitarian engineering are embedded in some of the universities, modern universities, new age universities in India. We have a new education policy where the word multidisciplinary is used very often, essentially indicating that we should integrate engineering and technology and liberal studies in general. In some institutions, particularly IITs, the first semester, for a month or so, the students are sent into the community to identify issues, identify problems, so that they can bring them back to the institution and try to obtain solutions. And of course, the capstone project is something else which is gaining a lot of attention. Lastly, I would like to say that the term humanitarian engineering is not commonly utilized. Even human engineering is more common than humanitarian engineering. From all the aspects that Professor Moore has pointed out, we should bring it into mainstream usage. Thank you.
Thank you, Dr. Natarajan. Any quick comment from you, Kevin, before we move on to other questions, comments?
I'm very happy to hear about sending the students out in the first year to begin getting them an understanding. I also want to say that I believe the global engineering deans that I've met over the years bring the mindset that the point of engineering is to make the life better. And that's a different mindset than I always find in the US. So that's very, very much so. I will finally say, we struggle a lot if the word humanitarian engineering is the right phrase, but it's a phrase we chose years ago and we stick with it. But it does require explanation, and it's not used everywhere, but the ideas are the things that are important as much as the name.
Okay, we have a comment question from Elsie, but before unmuting her, I'm going to read out a comment from a professor at a Indian university saying that this is exactly what needs to be done in all our colleges, but we have to start with small baby steps. So would you have, with your experience in minors in humanitarian engineering, would you have maybe 1 or 2 courses that you can guide the colleges to get started in this direction?
We give a very popular course at the second year or third year level called Socially and Environmentally Responsible Engineering, and I think that's a good course. The other baby step that many schools do is to make a course called Service Learning, where they actually will do some community project. But if you can curate that course so that the proper precepts are being given and the skills are given to them. And then we have the course called Engineering for Community Development, and I think that's a good starting place. So I think baby steps are to have one course and let the popularity drive the minor.
So would you be willing to share maybe your curriculum or something in maybe 1 or 2 or 3 of these courses with me so that I can give it to the audience and that's interested in this area in India?
Yes, certainly. I can assemble that information. At this point, we have some 6 faculty teaching these courses regularly, and they have well-developed courses, and some of them have been made available online. I didn't mention this, but we are offering a graduate certificate of 3 courses online. And so I can also provide that information.
That'd be great. Elsie, can you unmute yourself? I've unmuted you. You wanna, or I can read out what you said. Either way. Okay, go ahead, Elsie. Yeah.
Thank you, Krishna. Dr. Moore, thank you so much for this presentation. What you've described is essentially the most systemically aware approach to engineering that I have heard about so far. And I'm very glad to know about it. Just to give you a little background in terms of how you've branded your program, Humanitarian Engineering, the name of my company is Humanity, Inc. And it's no accident that I think business, and we serve businesses for social good. And it's no accident now that it is exactly relevant, the impact of whether it's technology or engineering or finance on the license to operate of businesses is right there in the stock market. And they are being penalized or rewarded based on how they're handling risks, such as environmental and social. So I applaud your focus. I have a question for you. I'm sad that I'm only learning about this now, but what is your appetite for bringing awareness of your curriculum to the broader business community, in particular those who are working at a systemic level? I'm thinking about the circularity movement. I'm thinking even at the World Economic Forum level, where there's an attempt to integrate technology and engineering and the sciences with human outcomes. What's your appetite?
We're certainly eager and willing to do that, I would say. I would say we've gone through an evolution of growth, and in our program we started a long time ago, but then we kind of had something of a hibernation for a few years and then restarted around 2014. And so we've really thought as a strategy that we needed to focus on getting it right locally with our curricular pieces. But we are actually looking to expand some of our activities in Latin America with some summer schools, etc. We would certainly be pleased to talk about what we're doing to people in a broader stage, for sure.
Okay. So we'll keep
Very
connected, Elsie. Yeah.
Thank you.
Krishna.
Ramiro, come in. Ramiro, you want to make a
Yes.
comment?
Thank you, Krishna. Thank you, Kevin. This was a great presentation. This is so much aligned with what we're trying to do with peace engineering.
Yes.
We're connecting now the legal aspects on policy and finance. So we did start a minor at UNM, and we're launching with the Peace Engineering Consortium a fully online master program and certificate program. We are inviting different institutions to add to this, so we would like to work with you.
Sure.
Something that is very important is that context awareness is so much needed in engineering, and the respect and preservation of culture. This is something that we really need to dive in on an understanding of the individuals. Also, the data is owned by the people that will be affected. So we're trying now to collect data in real time that can be bubbled up to these big organizations like the World Bank, and because they don't know what is needed. So data is it's a big project that we have, and of course, I think in terms of people finding a job, we provide the most of our talent to the national labs. The national labs want peace engineers. They need to connect the social science, the policy. And we're connecting now the medical school. Health sciences need to be, because we're all in this together. So I take my hat off. We have a lot of things in common, and I think we should just collaborate. And I think IFES GDC should create this forum so we can collaborate and not reinvent the wheel. Thank you.
Right.
All the best. Congratulations.
Thanks, Ramiro.
Yeah, thank you,
Let
Romero.
me give a chance.
Let
Yeah.
me
Go ahead,
make,
Kevin, you want to make a comment?
yeah, one quick comment, and thank you, Romero. I really like what's been happening with the Peace Engineering Consortium, and we'd be glad to work with you. Talking about the health sciences, I want to say that we have a sponsor who has been encouraging us to try to get involved and reach out on the CSR, the corporate social responsibility with big pharma. But frankly, that one is scarier than mining or anything, because but big pharma is a place where we really need the idea of socially responsible engineering. I mean, and just look at with the pandemic and the inequity worldwide with the vaccines. These are to move these ideas into health arena is so important.
Great. Let me give a chance to Juan Lucena. You want to unmute yourself? You have an interesting, good comment. Can you unmute yourself, or I can read it out for you? Go ahead, Juan. Yes, come in.
Can you hear me now?
Yes.
Well, first of all, I would like to thank my colleague Kevin Moore for an excellent presentation, and I guess the comments that we receive, that he has received afterwards, speak very highly of the way he presented our program. So thank you, Kevin. More than a question, it was a clarification from the intervention. I believe his name was Hans, the anthropologist, who emphasized again the need to take each other seriously. And one of the things that we have in our team of faculty is a group of anthropologists mostly, but also other social scientists who study engineers and engineering. That's what we do for a living. And Professor Jessica Smith, who is our lead anthropologist, this year is becoming the chairwoman of the International Network of Engineering Studies, which is the group of social scientists that studies engineers and engineering across cultures, periods, organizations, sectors, and so on. So I just wanted to put that in the radar screen of this audience, that there is such a network
Thank you, Juan.
at the international level.
Thank you, Juan. Thank you very much. I'm going to give Hans the last word here before we wind up. Come in, Hans.
I just want to say this is an amazing presentation, Kevin. I mean it. And Ramiro, I hear you deeply. What I want to do is for us to continue this dialogue, because it's not only what you're doing in the humanitarian, the creative work that Ramiro is leading at many, many levels. Our friend Bill Oakes at Purdue University. I can go on down the list. I think what we need to find IFES GDC opportunities to continue and deepen this conversation. Point one. Let me just again thank, of course, your presence, Kevin, this thoughtfulness that you've given, and of course, Krishna. I just want to, all of us who are here, this wonderful audience here, let's find a way in Cape Town as we come together in November, and I want to plant that seed for you to join us. People are beginning to come together face to face, and I'm very open and working very closely with our hosts in Cape Town in terms of that global event. And some of the issues that Kevin so thoughtfully and others had mentioned are included there. The other thing, just finally, and not related to this particular conversation, we are hosting a whole series of webinars with women engineering leaders that have contributed to the book of Rising to the Top. And Kevin, also thank you for your support in terms of the publication of that. And they are talking about their journeys in all 6 continents that they face as women engineers in the complex environments. And again, we have excellent engagement by those leaders in our webinar series. I just want to highlight that to you. With that, Krishna and Kevin, many thanks for your very, very thoughtful presentation. Peace be with you.
Okay, that's it. Good time to end the presentation, Kevin. Thank you so much, and everybody. We will be in touch with you. A lot of follow-up comments and questions will be there. So anyway, everybody, thank you. Be happy, be safe, and be healthy, and be cool wherever you are in hot places.
Yeah, thank you. Bye-bye. Peace be with you.
Yeah.